Okay, so this is AS1 Physics 1, and it's June 2005, question 5. First of all, we're asked to define resistivity, and resistivity is the resistance of a 1 meter length of wire with a cross-sectional area of 1 meter squared, and that comes from R equals rho L over A. So L is equal to 1, A is equal to 1, and the resistance will be equal to the resistivity. So the resistivity is the resistance of a 1 meter length of wire with a cross-sectional area of 1 meter squared. Probably better to write in there cross-sectional area. Student plans an experiment to measure resistivity, plans to take a reel of constantan wire, cut a number of pieces from it. First, the resistance of each will be measured. Draw a label diagram of a circuit using the ammeter voltmeter method. So we're looking for a battery, and then we've got the resistance wire that we're measuring. We need to measure the voltage across that, and we need to measure the current through it, and we need to have some way of varying that, so we need a variable resistor in there. So that allows us to change that. And for 2 marks here, I think the examiner's looking for voltmeter, ammeter, power supply, and the resistor all in the correct places. Okay, so assume the resistance of the piece of wire have been determined. Describe how the other quantities which are required to calculate the resistivity would be measured, include experimental detail. Now again, R equals rho L over A, therefore rho is equal to R times A over L. So we've measured the resistance, we now need to know the cross-section area and the length. So the length of the wire is measured using a meter rule. By stretching the wire along the rule and measure between, or measure from end to end, probably with the ends secured, one at one end, one at the other end. Cross-section area then, using a micrometer screw gauge, to measure the diameter of the wire at several points along the length. And then use area is equal to 4 pi d squared over 4. Okay, so area is equal to pi d squared over 4. So we use a micrometer screw gauge, so it's important that it's a micrometer screw gauge. Measure the diameter at several points to find an average value. I should maybe have said that. So you find an average diameter. And then use A is equal to pi d squared over 4. Having completed the experiment, the student writes a report and says the resistivity of the wire is 4.9 times 10 to the minus 7. Identify the 2 errors that are in this. Well, the first error is it's not the resistivity of the wire, but it should be the resistivity of the material. Resistivity is a property of the material, not of the wire itself. And the second mistake is the units should be not ohms per meter, but ohm meter. So the resistivity is the resistivity of the material rather than of the wire, and the units should be ohm meters for resistivity. Then the resistivity of iron is 6.7 times the resistivity of silver. An iron wire of length L and diameter D has resistance R. Obtain an expression for the diameter of a silver wire which is also of length L and resistance R. Alright, so we're going to say here then the resistivity of iron is equal to 6.7 times the resistivity of silver, and rho I, the resistivity of iron, is equal to, well, it's got a length L and diameter D, so it's rho is equal to, well, if R equals rho L over A, then rho is equal to R times A over L. You need to think about that. So that means that the rho of I is equal to the resistance, which is R times, and then it's pi times D squared over 4 divided by the length, which is L. The resistivity of silver then is equal to, well, it's got a diameter of silver wire, so that's equal to the same resistance times pi, and now this is, I'm going to call that capital D squared over 4 times L. So now what I can do is I'm going back up to this expression here, and I'm saying that R times pi small d squared over L, that's for the resistivity of iron, is equal to 6.7 times, and then that's R times pi big D squared, so that should be 4L over 4L. 4L cancels, the pi cancels, and the R cancels, so I've got that D squared is equal to 6.7 times D squared. So that means that D squared is equal to D squared over 6.7, or D is equal to D over root 6.7. So the diameter of the iron, or sorry, of the silver wire is D over the square root of 6.7. So again, we've just worked out what the resistivity of iron, the resistivity of silver. We've said that the resistivity of iron is 6.7 times that, so we put that in there. These all cancel down to leave us with D squared equal to 6.7 times that. Big D squared is what we're looking for, so big D squared is equal to D squared over 6.7. Therefore D is equal to D divided by root 6.7.